This video will cover the 2017 AP Calc free response number 5 and 6 from the BC exam. If you're looking for question number 4 is on my 2017 AP Calc free response AB exam, since question 4 was on both tests. All right, so let's get started with question 5. Question 5 says f of x is a function defined by 3 divided by 2x squared minus 7x plus 5. All right, so we have this function. It's a rational function. It says find the slope of the line tangent to the graph when x is 3. So we know the slope of the tangent line means we got to find f prime of x. So how are we going to find the derivative of this? I mean, we can just use the quotient rule if we want. All we got to do is plug in 3. So the quotient rule says denominator, 2x squared minus 7x plus 5, times the derivative of the numerator, 0, minus 3, right, numerator, times the derivative of the denominator, which is going to be 4x minus 7, all divided by 2x squared minus 7x plus 5 squared. So they want us to find f prime of 3. Now, what do we get when we plug 3 in here? This is going to be 12 minus 7, which is 5. So that's negative 15. And then on the bottom, we get 3, so that's 18, right? 18 minus 21 is negative 3 plus 5, 2 squared 4. So I came up with negative 15 over 4. And then what about part B? Part B says find the x coordinate for each critical point between 1 and 2.5. Classify each critical point as a location for relative max or relative min. Okay. So we got to find the critical points. Now we have our derivative, right? Our derivative turned out to be negative 3 times 4x minus 7 divided by 2x squared minus 7x plus 5 squared. Now we got to find the critical numbers here, right? So what do we need? We need to figure out when, right? This is part B. We got to find out when the derivative equals 0. So that would be, we take the numerator, 4x minus 7, set that equal to 0, we get x equals 7 over 4. Right, now they told us to look between 1 and 2.5. 1 and 2.5. Well, 7 over 4, of course, is 1.75. So that's one of our critical numbers. What about, does the derivative ever fail to exist? Well, we'd have to find the zeros of this, right? So let's take a look at the discriminant. We get b squared minus 4ac. What is that going to be? That's going to be 49 minus, right, 4 times 2 times 5. So that equals 9, right? And so, since it's positive, we're going to have zeros. So we can factor this, right? We can factor this. So, this could be embarrassing. 2x squared minus 7x plus 5. If we factor that, we're going to get 2x and x. We need a 5, right? We need something that multiplies together to give us 5. So we'll put a 5 there and a 1 there. And we need negative 7s to both of those. So our critical numbers here are x equals 5 halves, which is 2.5, and x equals 1, right? Now they said only find the critical numbers between, right, between 1 and 2.5, right? 1 and 2.5. That means this is out, right? This is a no, and this is a no. Because remember, we're looking for critical numbers between 1 and 2.5. They said 1 is less than x is less than 2.5. So both of those are equal to, so our only critical number is 7/4, right? So find the x-coordinate for each critical point. Classify each point as a location of relative max or relative min. So we can run the sign test if we want to do that, right? We're starting at 1, we're going to 2.5. We have 1.75 is our only critical number. What are our derivatives? Well, we have a -3. We don't our factors of our derivative. We have a -3. We have 4x minus 7. We have x minus 1. And we have 2x minus 5, right? So we need a number between here and here. Now remember, -3 is going to be negative. So we'll pick 1. Put a 1 in here, you get a negative. Put a 1 in here. I'm sorry, I can't pick 1. So let's pick 1.5. Put a 1.5 in here. You get a negative. Put a 1.5 in here, right? 1.5, you get positive. Put 1.5 in here. 2 times 1.5, right? 2 times 3/2 is going to be 6/2. That's 3, so that turns out to be negative, right? So, where do we go from here? Well, that's going to be negative, right? And then what do we get over here? You know, put in 2, right? Plug in 2. This is going to be negative. This is 8 minus 7. That's going to be positive. Put a 2 in there, you're going to get a positive. Put a 2 in there, you're going to get a negative. So this turns out to be plus over here. So we're decreasing and then we're increasing. So x equals 1.75 is a relative min, right? Relative min. All right. So that takes care of part A and part B. Now what about part C? Well, here we get to the real crux to the BC part of this, right? The BC part of this question is really, those are A-B concepts that we covered right there. Now what we're going to do from here on, of course, is going to be a more of a BC approach. Not more of it, it's going to be a BC approach. So what do we have in part C? Well, in part C, they give us an identity. They tell us 3/2x squared minus 7x plus 5 is really equal to 2/2x minus 5 minus 1/x minus 1. In other words, they already did the partial fractions for us. And they want us to evaluate the integral from 5 to infinity of f of x dx. This is an indefinite integral, so we know this is equal to the limit as t goes to infinity, the integral from 5 to t of f of x dx, which for us is going to be the limit as t goes to infinity, the integral from 5 to t of 2/2x minus 5 minus 1/x minus 1 dx, right? Because we have our partial fractions already simplified out for us. That was very nice of them, wasn't it? So, if we integrate this, right? If we integrate this, what are we going to get, right? We're going to get the limit as t approaches infinity. And here we could do a u sub if we wanted to, right? We could say u equals 2x minus 5. du would be 2 dx. We've already got that taken care of. How nice of them. So this is 1/u. The integral of 1/u, of course, is the natural log of the absolute value of u. So that would be 2x minus 5. Minus, this is a natural log as well, so that's minus the natural log of the absolute value of x minus 1. Right? So that's our integral. And we're evaluating this between 5 and t. So we get the limit as t goes to infinity, and now what do we end up with? We get the natural log of the absolute value of 2t minus 5, right? Minus the natural log, we plug in 5, and we get the natural log of 5. That's the fundamental theorem of calculus. Minus here, we get the natural log of the absolute value of t minus 1, right? Put another bracket around it because of this negative sign of the distributive property. Minus the natural log of the absolute value of 4. Now don't forget, we have to take the limit of this as t goes to infinity, right? As t goes to infinity. So what do we end up with here? Well, if we put all these things together appropriately, I would put this with this. It's minus. So this is the limit as t goes to infinity of the natural log. We have this one minus this one by the log properties. That's 2t minus 5 divided by t minus 1, right? And then we have that one minus that one, if memory serves there, right? So that would be plus, this one's positive, so that would be the natural log of 4 over 5. And now we're taking the limit as t goes to infinity. So as t goes to infinity, we have the same power in the numerator and the denominator. So this is the natural log of 2. We don't need the absolute value. Plus the natural log of 4/5. All right? And so what do we get there? We got log plus log. So that's the natural log. We can multiply those and we get 8 over 5. All right? So that's the answer to part C. Now, part D is very nice, right? Part D says determine whether the series sigma n equals 5 to infinity of 3 over 2n squared minus 7n plus 5. Determine whether this converges or diverges. State the conditions of the test used for determining convergence or divergence. Well, what do we know about f of x? Well, we know from our previous example, f is continuous on 5 to infinity, because we found it's where its asymptotes are. Its asymptotes are 2.5 and 1. That's not in this interval, right? So it's continuous on that interval, and it's decreasing, right? We found the derivative, and the derivative was negative. Why is that important? The integral test applies. So and the integral converges. So therefore this converges by the integral test because the conditions are here. So it converges. So we already did all the work in parts A through C to conclude that it converges by the integral test. Now, if you don't want to do that, right, you could do the ratio test or the limit comparison test. You could do some other tests, but you've already done the work, right? You've already done the work. So that's number 5. And then we have to do number 6. So let's go ahead and erase all this. So problem 6, right? Let me see problem 6. The function f has derivatives of all orders. The derivatives of f satisfy the conditions above. The Maclaurin series converges for x, absolute value of x less than 1. Show the first 4 non-zero terms in the Maclaurin series of f are. Now, we don't have to find Maclaurin series, right? So we don't have to do part A. Determine whether the Maclaurin series square product converges absolutely. We don't have to do that. Part C, write the first 4 non-zero terms in the general term of the Maclaurin series. Again, not on our test this year. Part D, let P sub n sub 1/2 represent the nth degree Taylor polynomial for G about x equals 0, evaluated at x equals 1/2, where G is the function defined. Use the alternating series bound. We don't have to do that either. So question 6 is out. So we're done. All right.